Have you ever wondered how a tiny electrical pulse can manage a substantial amount of power in circuits, acting like a swift and powerful switch? The two-transistor equivalent circuit for a thyristor is a powerful conceptual model that simplifies understanding its internal PNPN structure and how it functions as a controlled switch. This analogy works by representing the thyristors for alternating layers of semiconductor material, the p-type, n-type, p-type, and n-type, as two interconnected bipolar junction transistors, specifically one PNP and one NPN transistor. The collector of the PNP transistor is directly connected to the base of the NPN transistor, and conversely, the collector of the NPN transistor is connected to the base of the PNP transistor. This ingenious cross-coupling creates a positive feedback loop. When a small trigger current is applied to the gate, it causes a small current in the NPN transistor, whose collector current then feeds the base of the PNP transistor. This, in turn, boosts the PNP's collector current, which further drives the NPN's base, leading to a rapid and regenerative turn-on of the device. Understanding this two-transistor model provides invaluable insight into how a thyristor achieves its characteristic latching action. It clearly illustrates the conditions required to initiate conduction and helps predict the holding current, which is the minimum current necessary to maintain the device in its conducting state. It is not intended for physically constructing a thyristor with discrete components, but rather for analyzing its complex internal operation conceptually. This regenerative feedback, often referred to as the latching action, is the thyristor's defining characteristic, enabling it to conduct a large load current even after the initial gate trigger signal is removed, as long as the anode current remains above the holding current. This unique self-sustaining behavior, vividly explained by the two-transistor model, allows thyristors to control high power with a very brief, low-power control signal, making them indispensable in applications like motor control, power supplies, and lighting dimmers. By breaking down the thyristor's complex four-layer structure into a more familiar two-transistor configuration, this equivalent circuit demystifies its high-power switching capabilities and its distinct latching mechanism. It transforms an abstract semiconductor device into an understandable interaction of simpler components, providing a clear mental framework for analyzing and applying these critical power control devices in various electrical engineering systems.